Welcome, everyone, to today's explainer. I want you to picture something absolutely awe-inspiring. Just close your eyes and imagine a giant, futuristic elevator. But we're not talking about a skyscraper here. No way. This elevator stretches directly from the surface of the Earth, piercing right through the clouds and going all the way out into the dark, silent vastness of space. It sounds like pure sci-fi, right? But today, we're unpacking a really fascinating concept brought to us by Future Tech Insider. We're going to explore the mechanics, the monumental challenges, and the incredible promise of the space elevator. Okay, let's dive into this. I want you to personally ponder this for a second. Travel to space without a rocket? I mean, for all of human history, escaping Earth's gravity well has meant basically one thing. It meant sitting on top of thousands of gallons of explosive fuel and just holding on for dear life. Massive rockets, intense heat, bone-crushing G-forces, the whole shebang. But what if that wasn't the only way? What if leaving Earth could be, as routine as heading up to the top floor of an office building? That right there is the visionary hook we are exploring today. Section 1. No rockets required. Let that sink in for a moment. And this brilliantly illustrates exactly what we're talking about. We are standing at a literal engineering crossroads here. See, traditionally, we rely on controlled, massive explosions to conquer gravity. It's a method that is loud, insanely expensive, and honestly, it mostly requires burning fuel just to lift more fuel. The alternative? Well, it's a completely different philosophy of physics and engineering. Instead of a fiery, controlled explosion, we're looking at a smooth mechanical climb. Absolutely no explosions, just pure, brilliant structural engineering. Moving right along to Section 2, the ultra-strong cable. So a space elevator is exactly what it sounds like. Scientists have proposed an ultra-strong cable stretching directly from Earth into space. But to be clear, we aren't talking about stacking steel beams from the ground up to build some really tall tower. Actually, scratch that. It's more like a massive tensional structure. Think of a cable anchored right to the equator, reaching tens of thousands of miles up and held perfectly taut by the centrifugal force of the Earth's spin. And because it relies on that physical tension rather than rocket propulsion, it carries people and cargo slowly into orbit. Slowly and steadily. It's totally counterintuitive to how we normally view spaceflight, right? You wouldn't need to reach thousands of miles per hour. You wouldn't suffer those intense G-forces. You'd basically sit in a spacious cabin, watch the blue sky fade into blackness, and ascend at a steady, calm pace. Which brings us to Section 3, the material challenge. So the crucial point is that operating a structure of this unprecedented magnitude requires constant monitoring by brilliant engineers and highly advanced AI systems to ensure everything operates safely. But our ultimate roadblock right now is just physics. The elevator absolutely requires a material strong enough to support its own immense weight across thousands of miles of gravity. And today, no known material can fully achieve this. Not even steel, not even our most advanced carbon composites. They just don't possess the sheer tensile strength needed to pull this off. The science is theoretically sound, but we're literally waiting on a true revolution in material science to make it a reality. Section 4, cheaper and more efficient. Let's move to and see how this builds into the bigger picture. That slow climb ultimately ends at its destination, a massive space station anchored in geostationary orbit high above Earth. And this station isn't just a destination, it acts as the vital counterweight, keeping the whole cable taut. Once you arrive at this hub, the entire solar system is practically at your doorstep, all without the need to escape Earth's steep gravity well ever again. As the proposals state, a space elevator could make space travel cheaper and more efficient. And I mean, wow. Think about what that fundamentally means for humanity. Right now, space access is incredibly expensive because we're essentially throwing away multi-million-dollar rocket boosters into the ocean after every single trip. An elevator, though, it uses electricity. It's reusable. It's sustainable. It completely shifts space travel from being an exclusive luxury to an accessible reality for us. That is absolutely game-changing. Section 5. Would you ride it? Now, what's really interesting about this slide is the question it poses directly to you. Would you ride an elevator to space? It's a total mind-bending reality to consider. A slow, steady climb, guided by AI, with absolutely no explosive rockets beneath you. But you'd be hanging, suspended from a cable tens of thousands of miles in the air. So I gotta ask, if engineers crack the material code tomorrow and those elevator doors open, are you stepping inside? What a phenomenal thought experiment to leave you with. All of the incredible concepts we broke down today come directly from the brilliant minds at Future Tech Insider. If this explainer sparked your imagination, make sure to follow Future Tech Insider for more amazing future tech stories. They are constantly exploring the boundaries of what's actually possible. Thank you so much for joining me on this climb today. Keep asking big questions, keep learning, and I'll catch you on the next explainer.